Okay, guys, so this is video 2 from section 15.2. Here I will focus on second objective from this section, which is division of rational expression. Okay, so let me write the steps. So technically this is what you're going to have, the definition. You're going to have rational expression P over Q, and you're going to divide it by the second rational expression, let's say R over S. So what you're going to do here, you have technically fraction divide by fraction. So you're going to apply that keep change flip, which means you're going to keep your first fraction, first rational expression, which is P over Q. C stands for change. You will change division to multiplication. Flip means flip the second rational expression, which will be S over R. Or flip means multiply by reciprocal. And then you just follow the rules of multiplication, which means multiplying numerators together and multiply denominators together. And again, in this definition, of course, P, Q, R, S, I'm referring here to that they are polynomials. Q can't be 0, S can't be 0 because denominators never zeros. So let me write the steps. Step of dividing two rational expressions. Okay, so what we're going to do here, first step, change the division to multiplication. Okay, which means keep the first fraction. By fraction, I mean a rational expression, and multiply by the reciprocal of the second fraction. Okay, so that's the first step, that keep change flip technically. Second will be follow the steps, because now we have multiplication, so follow the step of multiplying rational expressions. Which means, let's review them. Factor both numerators and denominators. Then you're going to cancel repeating factors. Of course, the one which repeats on the top and on the bottom. And then you're going to multiply numerators and denominators together. together. Okay, so let's solve the examples. Okay, so this is example 2, dividing rational expressions. Okay, A, we have 7y minus 14 over y plus 1 divided by y squared plus 2y minus 8 over 2y plus 2. So first what I'm going to do, okay, I'm going to follow the first step, change the division to multiplication. Super important, okay, we don't want to forget about this by using that keep change flip. Okay, so first we're going to apply that keep change flip. You're going to keep your original first rational expression. So keep your first fraction, which is 7y minus 14 over y plus 1. C stands for change. Change division to multiplication. And flip means flip over the second rational expression. So what used to be on the bottom will be on the top. What used to be on the top will be your denominator. Okay, so now this is the one which we're working with, okay? We're never going back, so this is the one which we need to simplify. So what I'm going to do, I'm going to do the same work which we did for multiplication, because now our division become multiplication. So I'm going to factor each. I'm going to factor first 7y minus 14. Okay, so GCF, greatest common factor is 7. Let's factor 7 out. We end up with y minus 2. So 7y minus 14, I'm going to rewrite as 7 times y minus 2. Okay, next, I'm going to factor y plus 1. Since y plus 1 is prime, why it's prime? Because the GCF, greatest common factor, is only 1. There's nothing else. So we're going to keep it the way it is. So let me rewrite that as y plus 1. Next, I'm going to factor 2y plus 2. Put it here, so let me separate them. So factor 2y plus 2. The greatest common factor is 2, so we're factoring 2 out. 2y divided by 2 will give you y. 2y divided by 2 will give you 1. So we end up with 2 times y plus 1. So let's put that as 2 times y plus 1. And last one, the one which takes the most work, we're going to factor this quadratic expression. So next, we're going to factor y squared plus 2y minus 8 using AC method. So this is that easy case because A is equal 1, B is equal 2, C is equal negative 8. So we have a nice case, okay? Because of the leading coefficient equal 1. So what we're going to do, we're going to multiply A times C, and we end up with negative 8. Then we're going to find two integers, which by multiplication give us -8, and two integers, which by addition gives you b, which is 2. So what's going to work? 4 and -2. Okay, and now we're going to create two factors. Y plus 4 times y minus 2. Okay, we don't need to worry about factoring GCF because the leading coefficient that a was equal 1. Okay, so let me go back to our problem, and y squared plus 2y minus 8 we're going to rewrite as y plus 4 times y minus 2. And now I'm going to start canceling the factors which repeats on the top and on the bottom. Y minus 2 is on the top, y minus 2 is in the bottom. Cross them out. Then I have y plus 1 on the top, y plus 1 on the bottom. Cross them out. And that's it. There is nothing else what I can cancel. So now we multiply numerators together. So 7 times 2 will give us 14. And multiply denominators together, so we only have y plus 4. So this is our final solution. So technically we follow the same steps which we learned in a previous video. The only thing what we need to remember, the step 1, when we're switching that division to multiplication by multiplying the first rational expression by reciprocal of the second rational expression. Okay, let's do more. Let's do B. So here, example B, we have 4x squared minus 9 over 2x squared minus x minus 3 divided by 20x plus 30 over x squared plus 7x plus 6. So step number 1, we're going to change division to multiplication. Keep, change, flip. So we keep the first fraction. We're going to change division to multiplication, and we're going to flip over the second fraction. So x squared plus 7x plus 6 goes on the top. 20x plus 30 will be on the bottom. Okay, and now just follow rules of multiplication. So let's start factoring. Factor 4x squared minus 9. Okay, so here you will use difference of two squares formula. We already know the formula. This is the same as a minus b times a plus b. So in our case, you can rewrite 4x squared as 2x to a second power. 9, it's a perfect square of 3. This is the same as 3 to a second power. So now your a will be 2x from the formula of difference of two squares. B, it's equal to 3. So the formula is a minus b, which will be 2x minus 3, times a plus b, which will be 2x plus 3. Okay, so we have it. 4x squared minus 9. This is the same as 2x minus 3 times 2x plus 3 over. Now, let's take care of the quadratic. Factor 2x squared minus x minus 3. using AC method. So here watch out, because your leading coefficient A is not equal to 1. Okay, so we'll need to do a little more work here. So A is equal to, B is equal -1, C is equal -3. Step 1, multiply A by C, and we're getting 2 times -3, -6. Step 2, find two integers which product is equal to AC, which is -6, and the same two integers by addition will give you B, which is -1. So what's going to work? -3, +2. Okay. Next, don't forget here that A is equal to, so you have to create two factors. 2x minus first integer and 2x plus first integer, which is plus -3, times 2x plus second integer, which is 2. Now, since A is not equal to, so you have to factor out GCF and ignore it. That's the algorithm which you teach you. So 2x minus 3 is prime. No GCF. Or you can say that GCF is equal 1. So we're going to keep it. Okay. Now 2x plus 2. The GCF is equal to, so we're going to factor 2 out, and that will give us just x plus 1, and we're going to ignore it. So we only keep x plus 1 and 2x minus 3. So going back to our so 2x squared minus x minus 3, our quadratic equation, we're going to rewrite as 2x minus 3 times the one which I have in yellow times x plus 1. So let's go back to original problem. And again, 2x squared minus x minus 3, we're going to rewrite as 2x minus 3 times x plus 1. So we have it. Next, okay, here we go. We need to factor quadratic equation. X squared plus 7x plus 6. Okay, so let me show work for this one here. So factor x squared plus 7x plus 6. The same thing using AC method. Here we have easy case because A is equal 1. So we don't worry about finding GCF and factoring out GCF. So A is equal 1, B is equal 7, C is equal 6. A times C is equal 1 times 6, which is 6. We're going to find two integers, which by multiplication give us A times 6, A times C, which is 6, and the same two integers by addition give you B, which is 7. So 6 and 1 definitely excuse me, works. So now our factors will be x plus 6 times x plus 1. So we're going to rewrite x squared plus 7x plus 6 as x plus 6. Again, we are right here, times x plus 1. And last one, we're going to factor 20x plus 30. So factor 20x plus 30, the GCF is equal to 10. So we're going to factor 10 out. We'll end up with 2x plus 3. So let's go back. And this is the same as 10 times 2x plus 3. Nice. All that work, but we have it. And now what we focus on it, we focus on multiplying this rational expression. So let's see what we can cancel. 2x minus 3 on the top, 2x minus 3 on the bottom. Cross them out. 2x plus 3 on the top, 2x plus 3 on the bottom. Cross it out. X plus 1 on the top, x plus 1 on the bottom. So what we have, remaining factors from numerators, it's only x plus 6 over, and remaining factors from denominator, it's only 10. And that's our final answer, x plus 6 plus 10. Okay, I have 2 more examples. So again, you guys in charge of your learning right now, if you think that's enough, go ahead, start working on your assignments. I'm going to show you how to divide those steps fractions, as I didn't show you the example like that, so I want to go back. And then the last example will be about multiplying and dividing rational expressions, so when we have mix of everything. Okay, so C. Divide. We have A to the third power b over 9c over 4ab over 3c to the third power. So when you have like steps like that, okay, like you see it's a lot. So what you're going to do, okay, try to find where is the division, okay, which fraction bar represents division. So technically always the one which divides that entire expression in half. So this is our division, okay, right here. This is the division. So what I want you to rewrite, to see that better, you can rewrite this as a to the third power b over 9c divide by 4ab over 3c to the third power. So again, find that division fraction bar, okay, which is technically in the middle of that entire expression. Now, what we're going to do, keep change flip. We're going to keep the first fraction. So we're going to keep a to the third power b over 9c. Change, we're going to change that division to multiplication. Flip, we're going to flip the second fraction. So 3c to the third power goes on the top, 4ab goes on the bottom. Now you just have multiplication. So we follow the rules of multiplication. Factor each expression. Here it's a nice one. So let's take care of a to the third power b. A to the third power is the same as a times a times a times b over 9c. Again, you can rewrite 9 as 3 times 3 times c times 3 c to the third power we can rewrite as c times c times c over 4ab. 4 again we can break down into two factors, 2 times 2 times a times b. And now we're going to cancel the factors which repeats on the top and on the bottom. I have a on the top, a on the bottom. And technically that's it if we're talking about a. Then I have b on the top, b on the bottom. Now I'm moving to the next fraction. You have 3 on the top, 3 on the bottom. Cross them out. We have c on the top, c on the bottom. That's it if we're talking about repeating factors. So now we have a times c over 3 times 2 times 2. So I multiply numerators together and denominators together. Let's simplify this. A times a is a to a second power. C times c is c to a second power. And 3 times 2, which is 3 times 4, will give you 12. So we're having a squared c squared over 12. Okay, and I just want to make sure that we see that this is a, not 9. Okay, so that's our final solution. And the last problem, example D. In example D, it's going to be mix. Okay, so this is mix of multiplying and dividing rational expressions. Okay, so let me show you one example. V over v plus 2 divide by 5v squared over v squared minus 4 times v over 10. So a couple things about this one. Like you guys see, you have two operations, major operation, division and multiplication. Which one to do first? So this is, again, many times they posting on Facebook, okay? Some mathematics problems with order of operation. Don't forget about the basic, which is PEM DAS, okay? So parentheses, exponents, okay? Now, but I'm talking about this part, multiplication and division. PEMDAS, it's technically just to help you to memorize which order of operation you do first. But if we have multiplication and division, what you're going to do, you doing the operation, which is the first one from the left. Okay, so the first one from the left is the division. So in this case, we're going to divide first. This is what you need to focus on at first. Okay, multiplication, division. Okay, they have the same strong order. So again, if you have both of them, you just follow the order from left to right. So first we're going to divide. Okay, so divide first. How? By keep, change, flip. Keep v over v plus 2, change division to multiplication, and flip the second fraction. So v squared minus 4, it's on the top, 5v squared, it's on the bottom. So we have it. And then you just copy this multiplication. So we have times, and just copy the remaining factor, v over 10. Now we only have multiplication, so we don't need to worry about anything. Okay, so what we're going to do, we actually have three rational expressions which we multiply. You're doing the same work like multiplying two rational expressions. So first you need to factor each. Okay, v, again, there's nothing what you can do with v, so just copy. V plus 2, it's prime. There's nothing what you can factor, so just copy. Times v squared minus 4, you can factor. Use a squared minus b squared formula, which is difference of two squares. A minus b times a plus b. Okay, so in our case, v squared minus 4 is the same as v squared minus 2 to a second power. So a it's v from the formula, b it's 2. So that will become v minus 2 times v plus 2. Okay, so v squared minus 4 we're going to rewrite as v minus 2 times v plus 2 over, and now I'm here 5v squared. So you can rewrite that as 5 times v times v. And now I'm here times, and we have the last fraction, you have v, so just copy that v, over 10. 10 you can rewrite as 2 times 5 equal. So let's focus on our multiplication here. We have v times v minus 2. Again, this is where I'm working. We're multiplying all of them right now. Okay, so let's start canceling. V is on the top. Okay, couple things here. Don't do that. You cannot just say, okay, this one and this one cancel. Okay, make sure that you're not forgetting that v plus 2, and that was my mistake. When you have expression, put in the parentheses so you don't do the mistake which I just showed you, because it happens a lot. So what we're going to cancel? V is on the top and v is on the bottom. V minus 2, okay, will stay. Then I have v plus 2, which is on the top, v plus 2, it's on the bottom, cross it out. And then this v will be cancelled with the remaining v from the bottom. And technically that's it. So let's rewrite that. Now what we're going to do here, we're going to multiply numerators together. So that will give us v minus 2 from numerator. That's it, because everything else cancel. And in denominator, you have 5 times 2 times 5. So we have v minus 2 over 10 times 5, which is 50. And this is our final solution. Okay, that's it. So this is the end of section 5.2. Okay, thank you for watching.